Hello and welcome. Today's video is going to be about the AOI toolkit, or in other words, all our yesterdays, a toolkit to explore web archives in Google CoLab. Presenters today will be myself, Tim Ribaric, and my colleague, Sam Langdon, and we're both from Brock University in the Digital Scholarship Lab. So I wanted to just start off by talking about the motivation for this project and why we got here. When we work with the web archives, particularly in their rawest form, we often get them as work files. Work files are often very large in size. They're difficult to move around, and there's no real standard desktop tool that will allow you to look at a work without a lot of fussing. And then the other sort of part of that is you often don't want to look at the contents of a whole work file anyways. Sometimes you would often want to just look at a subset of data that matches certain domains or, a certain period of time, not the whole complete thing. And yes, we're heavily influenced by Star Trek, the original series, in our putting together of this project. So we wanted to make a toolkit that scaffolds up to an environment that will create derivatives from those works and plot out some basic analysis steps. So those of you familiar with the new ARC tool in the Archivit platform, it sort of builds on the output of that tool. So what are we looking at here? The ARC platform is a addition to the Archivit platform that's being worked on by the Archives Unleashed initiative. They do great things. And it's an integrated derivative generator. So basically, if you have access to the platform, you navigate through and tell from a bunch of pre-specified derivative generation scripts different things you want created. So on the right side of the screen is a little bit of a screen cap that describes some of the basic options. So basically, you could say, give me the full text, just the full text of the web pages inside this work, and then off it goes. So the idea is you want to be able to connect this derivative product from this platform, or as we'll see in AOITK directly, you can create this derivative if provided a work. And then it scaffolds up an environment in Google CoLab that lets you do some analysis of the derivatives. So what do you want to do with your derivative? What are the different things that are most often tried when we have a bunch of text from web pages? And the other thing too is this toolkit will help guide you through some common investigations to save you from having to sort of start from scratch, particularly if you don't have lots of experience working with CSV files, which are ultimately what these derivatives are. However, Google CoLab is a great place to sort of scaffold up and create an environment that runs pretty consistently to let users experiment with these files and to create general different pieces of analysis. So on the right side of the screen is a bunch of notebooks that we made for the Google CoLab environment on a grant project that we worked on the past couple of years. And this was the motivation to our AOITK setup. So if you wanted to have a look, I'll share links to that project and all the derivatives that generated. We've submitted a manuscript to the Canadian Journal of Communications. So hopefully we'll have some published research about the analysis we did there.
So with the basics described, I'm going to throw it over to Sam, who will do a couple of demos for us.
So we're going to demo the derivative generator notebook for AOI. So this is a really great tool as an alternative to ARC, or if you don't have access to the ARC platform. So the derivative generator notebook, we can just open in CoLab. That'll just take a second. And here we are. So the first thing that we're going to do in the derivative generator notebook is we're going to have to install a bunch of libraries. Also a warning, this was not authored by Google. So we're going to install a bunch of different libraries that are going to allow us to work with web archive files and create those smaller CSV derivative files that we'll be able to do analysis on. So installing all of these packages is going to take a couple of minutes, and then we'll be right back. All right, so all my setup is complete. It took about a little under a minute and a half. And I've also connected to my Google Drive. So that's going to allow me to access my Google Drive files and also save my derivative files directly into my Google Drive. So the next thing we're going to do is run this cell, which is going to set up our derivative generator, and it's going to allow us to pick a place to save our derivative files. So anywhere we want to read or write files from. By default, it's going to be this AOY folder. So I'm just going to set that as my path. The other really great thing about the derivative generator notebook is that if you don't already have your WARC files or your ARC files saved in your Google Drive, you can use the notebook to directly download them if they're hosted somewhere. So for instance, I'm going to download this file, which is hosted on GitHub. So this is a ARC file, which is part of the Canadian Political Parties and Interests Group Archivit collection, collected by the University of Toronto Libraries. You might have a web archive file set up in some kind of S3 instance or something like that. So you can directly download it to your Google Drive right within the notebook. And then I'm going to select my web archive file from my Google Drive, and I'm going to output it into a folder. We're going to call it U of T CanPol. And then you can pick what kind of content you want to have in your derivative. So right now we have options for text content. In the future, hopefully there will be options for other kinds of derivatives. But for now, I'm going to select text content without HTTP headers, and I'm going to click Create Derivative. So because these files are quite large, this can take some amount of time, anywhere from like 30 seconds to a few minutes, and then we'll get a CSV file output. All right, so my derivative file has been generated and it's saved into my drive at U of T-CanPol. So I can see here in my AOY folder, if I just refresh. So I can see in my AOY folder in my Google Drive that I have my U of T CanPol derivative. So it's this really big CSV file. It's going to take some time to load. And in it, we have our different crawl dates, our domains, the URL of the full URL of our website, and then the text content that was on that website at the time that it was crawled. So these CSV files will allow us to do a lot of further analysis on the website or on our web archive using our analysis notebooks, which we'll see in the next demo. So now we're going to demo our collection analysis notebook. So starting again from our homepage, we can go down here to analysis notebooks and open up our collection analysis notebook in Google CoLab. I'm going to save a copy to my drive to work with locally. So the first thing that you're going to do in this notebook is mount Google Drive so that you can access the derivative files that you have saved in your Google Drive, perhaps from using the previous derivative generator notebook or that you've uploaded from some other service. So now that Google Drive is mounted, we can download and install the All Our Yesterdays toolkit. Again, if you want to change your working directory, you can use this pane to do so. By default, it's going to be the AOY folder, and I'm going to leave it as the AOY folder. So now we can load in our data. So this is the data file that I used in the derivative generation notebook demo. But for this demo, I'm actually going to load in the Niagara sample data. So we're going to select that file. And now we can just look at our raw data. So here we have our crawl dates, which have all been processed to be a date format, a list of domains, and then full URLs along with the text content of our web pages. So now to kind of explore our collection a little bit, we can look at the top domains in our data set. So there are 301 different domains in this Niagara sample data set, and here they are listed in order of how many total times that domain appears in the data set, so how many crawls we have of that domain. So in this case, we have brocu.ca is the one that we have the most crawls for with 1,717. And then second is Twitter with 465 crawls. And this widget will allow us to look at more or less of our top domains. So you can kind of just get a sense for what domains are in your data set and how frequently they occur throughout the data. So you might want to look at just maybe your top 3, or you might want to get like a much wider view and look at the top 50 or something like that. So this will allow you to sort of get a sense for what is in your data. And next we can look at that same idea, but from a slightly different angle. And so we can look at the number of crawls we have of each domain in a given time period. So by default, this crawl frequency widget is going to let me select my entire data set. So this data set goes from April of 2020 to the end of 2021. And we can choose the number of top domains that we want to look at. So I'm going to pick the top 8. And then we can choose our time scale. So I'm going to look at the number of crawls per month for each of my top 8 domains. So we get this little visualization. And you can see that each of our like colored polygons here is representing the number of crawls we have for that domain in a given month. So we have, Brock obviously has a lot. And then YouTube, we can see there's this big spike here. And this sort of visually gives you a sense for how many data points you have for each domain in a given time period. We can also look at this visualization from a different angle, just to help us see the data a little bit better. So the nice thing about this widget is we can also constrain our data set by time. So maybe I'm only really interested in things that happened in that initial like summer of 2020, and I only want to see crawls up until the end of August. So you can create that visualization. In this case, that's not a lot of months. So we can see our visualization here is pretty blocky. And so another thing we can do is we can change the time scale. So maybe we want to know for each week how many crawls we have. So we can kind of increase that granularity that we're looking at the data with. So we can see here there's some weeks where we don't have any crawls for the St. Catharines standard domain. And you just get like a better sense for each week how much data we have over that shorter time period. We also have another option if you don't want to look at this 3D visualization. We have a 2D visualization that we can create. And so this is showing the exact same concept, how many crawls we have per week for each of our domains. But now the smaller dots are going to indicate a smaller number of crawls, and the larger dots are going to indicate a larger number of crawls. So again, this just sort of gives us an overview of the composition of our data, and we can kind of look and see what sort of data is there in our web archive collection, and then maybe gives us more of ideas of what we want to dig into, and maybe more fine-grained analysis, what sort of data we have to look at and to examine. So that's the collection analysis notebook right now.
Okay, what we're going to do here is demo AOITK's topic modeling tool. So first, just a quick look at our Google Drive AOI folder that has our CSV files of some derivatives. We jump back to the project's homepage, scroll down to the launch button next to topic modeling. So now a new screen shells. We can copy to Drive to get a local copy that we can return to. And then we start just hitting the run button in all of our code cells. So some of these cells take a little bit to run because they are pulling in lots of different data. However, the end user won't need to do anything particularly complicated with them. So now the platform is prompting us to connect to our Google Drive where our files are stored. All right, now we're told we're ready to proceed. We jump to our next code cell. We hit the run. Select our derivative file and set how many topics we want our topic model to build. I'll start with 5. So once we're at this stage, we can actually take a look at the data that's in a data frame that we just pulled in through that derivative. This is interesting if you want to explore some of the dynamics of the data before you get into building the topic model. Our next code cell here does the bulk of the work. So it sets up all of the different text processing functions that need to be done and prepares all the text from the derivative. Okay, so the model text has been processed and it's ready to build the LDA topic model. What is really great about AOI is that you can just hit the run button and watch all the output, or you can actually change parameters and tweaks if you've experimented with LDA before. We're not going to do anything except run this next code cell though. And once again, we're going to wait a little bit of processing time to get our model generated. Okay, so that took about a half a minute total, but in the end now we have a fully formed LDA topic model that's visualized in the probably familiar LDA viz library. So we can explore the topics, see what their main contributions are and whatnot. And then at the very end, we can actually save our model so we don't have to build it all again in Python. We'll just run the code cell. It dumps it into our directory of where our AOY files are. We'll jump over here just to demo. See, now we have a folder called models. We double click on that and the actual LDA model files have been built and saved so we can return to them and use them directly in visualizations or analysis without needing to rerun the whole model build again. So we'll just wrap up with a few last things here. I just want to say thank you to a couple of different grants that made this work happen. Archives Unleashed grant for the Niagara COVID Archive project, an internal Brock University Match of Minds grant to develop the software. And also we're working through a different Match of Mind grants to do some user testing for the notebooks, and the notebooks we hope to wrap up with. So into the future, we want to, of course, complete the base set of notebooks for all the different types of derivatives. So we have something everyone can dig into no matter what derivative you're using. Complete our API documentation. And then finally, also putting together some developer documentation. One of the interesting things about developing a CoLab is that it's not a permanent environment. So pushing and pulling to GitHub with your completed code is a little bit tricky. And then, of course, the homepage for the project, if you're interested, is brockdsl.github.io/AOYTK. I'm sure at this point, Googling it would find it for you as well. And also, we're looking to grow the community behind the software by getting some collaborators or some testers together, or if you have an idea for a project that could use this code either for class purposes or research purposes, please drop us a line, dsl@brocku.ca. Thank you very much.